With the first bite of the pneumatic drills, the TV cameras were rolling. But that night in Oxford Circus, only a small crowd looked in. It was the weekend. Most people were out of town. And the models who saw it all in the fashions of 6 years ago couldn't talk. So an operation began which had been on the drawing board for 18 years. It was, of course, raining. This was D-Day.
The Tube is a bit of London's pride that's been handed down to us. Back in 1863, when London pioneered underground railways, it was properly the wonder and admiration of the world. It still might be in 1969, if there weren't so many of us. Too many people for the system to digest. No strap hanger, and none of the rush hour crowds pressing wearily over the pavements above needs telling that today the Tube is bursting at its seams.
It's the same problem which London, paradoxically, has inherited in the drainpipe system. But in this overcrowded metropolis, we have a national tradition of adventuring against difficulties. In Victorian times, the great engineer Sir Joseph Bazalgette enclosed the Thames inside the embankment and built the main sewers to support 4.5 million people, essentially the same system trying to cope with 10 millions today. In the 18th century, we established the canals, waterway roads. In the 19th, we led the world with iron horses. In the 20th, the technological age, it may be that the descendants of the Industrial Revolution are not so unworthy after all. Look at this, London. Here's the plan, conceived decades ago, to relieve the indigestion of London's traffic by tunnelling a new tube line from Victoria to Walthamstow. Twin tunnels of 10.5 miles to link 4 mainline termini, Victoria, Euston, King's Cross and St Pancras, to slash right across the existing system and bring the underground to a new region in the northeast. By any standard, it was a hell of an undertaking. No one knows all the secrets which lie under London's streets. The advantage the new pioneers had, in place of the picks and shovels, hammers and anvils of their forebears, were the machines of modern technology. But when the first great drilling rig arrived for the start of the work in Oxford Circus, one of the belly buttons of London, it was still the beginning of another brave adventure. In the autumn of 1962, the first phase was something of a small miracle. Before they could begin mining underneath, they had to erect an umbrella, a steel overpass for the traffic streaming overhead from the 4 points of Oxford Circus. For 60 years, a period as long as Queen Victoria reigned, rarely had anyone probed deep into the guts of central London. No one was even absolutely sure where all the power cables, gas mains and sewers were sited. Some went even mapped. But engineers playing with the stuff of the earth have to be gamblers. Gamblers with a system, but keeping their fingers crossed every time they go down for an inspection. 25 holes had to be drilled and filled in 18 days. 3 feet in diameter, up to 50 feet deep to get a footing in the London clay. As they were completed, the boreholes were sealed. Oxford Circus was almost ready for the opening of its steel umbrella. To the outsider looking in, it all seemed chaos. Civil engineering usually does. But in fact, brute force and the muck of it is combined with a pernickety and almost an embroiderer's precision. Isolated in an island of noise, encompassed by the swirling West End traffic, the surveyor and his assistant worked with the calm concentration of an operating theatre. They had to. The steel deck sections had to fit together without nuts, bolts or rivets like a jigsaw. Otherwise, it would be a spillikins. They got it right to fractions of an inch. Came that August bank holiday of 1963 when traffic and pedestrians were diverted. On the Saturday, the steel parts of the new umbrella, colour-coded and numbered, were ready. The target was that Oxford Circus had to be open for traffic by 6:30 a.m. on the Tuesday. Here's the story of a mere 65 hours. The first girder went into position at 3:20 p.m. on the Saturday. Later that afternoon, the centre rib was nearly complete. 7 o'clock, the first deck section went in. The night shift took over, and the sections continued to fit. On Sunday morning, 11 a.m. exactly, half the umbrella was complete. 43 hours to go. Sunday night, 30 hours and 40 sections to go from midnight. The one that doesn't fit has got to be this one. It's the last, and it does. 245 units in position in an average time of 11 minutes each. Just after midday on the Monday, with 18 hours to finish off the details, it was all over, bar the congratulations. Under the umbrella, with the traffic swarming overhead, this is what they found. A maze of pipes and conduits, power lines and drains. Just 2 feet, 6 inches under the road surface, London spilled over like a plate of spaghetti. From London on top to London underneath. While they got to work at Oxford Circus, constructing the new ticket hall, escalator shafts, stations and subways, all along the line, men and gear were lowered down working shafts dug to tunnel depth. They did their shifts in small gangs, 70 feet below the surface, in a secret, sweaty world of their own. Like moles, they tunneled towards the next gang along the line. Nothing new, man's instinct to tunnel, mucking out mud, shifting soil to the surface. It's been going on since the Stone Age. It's just that the methods have changed somewhat, the costume. The Stone Age tunnellers at Brandon in Suffolk used the tines of deer's antlers to scratch flints for their arrowheads out of the chalk. tunnelling through London clay with some sort of digging shield has been practical since 1825. The first one had 12 frames side by side with 36 cells, in each of which a miner worked at the face. We've advanced since then. A gang of 6 men working a modern rotary digger can clear a running tunnel through the clay at the rate of 2 inches a minute. The machines, lowered down the shaft to be assembled on the working site, can steer their tunnel accurately within a tolerance of 1.5 inches. They cut exactly to the diameter required for the passage of the trains. London clay, famous in tunnelling history since the 1890s, is the ideal medium in which to build a new tube railway. But it isn't self-supporting for very long. So the tunnel lining ring must go in quickly behind the digging shield, 1 lining ring every 2 foot advance. Once every 15 minutes, the miners assemble a self-supporting ring of concrete behind the digger. No nuts or bolts, they just pack the segments under power and pressure into place.
Up!
The miners are specialists, working as a team, in demand the world over where there's a tunnel to be dug. They stick at it for 8 hours a shift, sometimes working 2 shifts in succession, so that they only have to have 1 bath for double money. They earned a lot of money, and they sweated their skill for every penny of it. Think of them when you yourself are riding in comfort through the shotgun tunnel of the new tube. Behind the shields, cutting the tunnels, there are long sleds and belt conveyors to get rid of the spoil. If you dig a tunnel, as any rabbit knows, you must get rid of what you kick out of it. Muck, that's what they call the clay, comes out fast. Skip trains haul it away from the diggers and a belt conveyor to the surface. Where does it all go to? It's being dumped in worked-out gravel pits, in clay quarries, and even used to make bricks. It's probably true that what makes the land of Britain has been pushed about by industrious humans more than any other country in the world. And there's why we're doing it again. Underneath, and the miners are clawing at the tunnel face to make a new artery for London. The first breakthrough, and the meeting of 2 tunnels is coming about. And the engineers, those cool men, are satisfied. Somebody else seems rather pleased with the result. Running tunnels are best cut with mechanical diggers. Big diameter tunnels with cast iron linings are dug more economically by hand. Stations have big diameter tunnels. Londoners had little notion what was going on under their feet as the labourers laid into the Oxford Circus underground complex in 1965. It was work for big, strong and enduring men. For men with iron in their arms and buttocks for the shovel rather than the machine. It was a return, in some respects, to the methods of the Victorian engineers. Muscles to match the iron determination to face the task. Where did they come from? where have they come from so often in the story of these islands? Sons of Ireland, almost all of them, descendants of the formidable navvies who dug the canals and laid the railways, the men who astonished Europe when the canals were cut in the 19th century by cooking steaks in their spades over their bonfires. Back again, better paid, with pneumatic drills to help, to mine the new Victoria line. Men with big appetites, mighty thirsts. It wasn't all plain sailing. While London slept, at a weekend in October 1965, a diversion was necessary at Finsbury Park to make life easier for future Victoria Line passengers. As a tremendous concession, the engineers were given 15 hours without trains to effect the changeover. As the last train of the night went through, and the passengers caught a fleeting glimpse of what was in preparation. An army of men ripped up the rails and sleepers. Old Track was levered away. All hell broke loose.
Right, lads.
Temporary craneways, built specially for the job, lifted the awkward loads onto wagons, which carried them away down the old tunnel. Every man on the operation was briefed exactly what he had to do. Millions of commuters would have asked the reason why, if anything had gone wrong. But early that Sunday morning, the commuters were at home. Every move was meticulously timed. Old track removed, new track in readiness, new signals in the process of installation. What they did that night reminds me of the miracle of improvisation which was achieved on D-Day in the war. Apparently, we haven't lost something of the drive, at any rate, that we had then. Today, as always, we're much too inclined to blame ourselves for what we failed to do. But this was a neat bit of work, even if it was only a little bit, to divert an underground railway from an old line to a new one in 15 hours. The first train came through as scheduled on Sunday afternoon. Have I made the undertaking sound too predictable? It wasn't. Although London clay works well enough, the blue carpet underneath has holes in it. One of them is at Euston, where the line goes down to beds which are as waterlogged as a wet sponge. To prevent the water squeezing through into the tunnels, the workings had to be sealed off. High air pressure kept back the water until the work was done. It was like an episode in Doctor Who. But the engineers had anticipated all this. What they didn't expect happened in September 1964, under Green Park. A tunnelling shield working in the clay ran into an unknown pocket of water-bearing gravel. They had to dig the rig out. The wonder is that in a vast engineering undertaking, an investment of £70 million so far, that was the worst that happened. There have been few comparable engineering achievements so bold and at such a small price in human error. During the hottest summer weeks of 1966, the engineers knew exactly what they were up against. At Tottenham, the ground was so wet that even in a heat wave, they had to freeze 500 cubic yards of it so that they could excavate and line an escalator shaft. If you have a scientific bent, liquid nitrogen 350 below freezing point Fahrenheit. King's Cross was another cross to bear. Railwaymen know it as the menagerie. The reason why is that so many systems above and below each other converge here. Through main lines from the Midlands and the East Coast. Cut and cover underground railways. The Met and the Circle, the Hotel Curve and the widened lines. Deep tubes too, the Northern and the Piccadilly. King's Cross is riddled with railways. The Victoria Line, the newcomer, has been threaded through the eye of a needle. To get it through, and under an overjob, without old tunnels collapsing or lines distorting, specially strong tunnelling shields with more than the usual number of rams were used to support the clay at the face. The new tube station was lined with steel rings instead of cast iron, and the stresses arranged so that they reached not into other tunnels, but into virgin ground. The result of it all? Well, King's Cross still stands where it did. The crowds milling round Oxford Circus tube station while the work was going on had cause to wish the place to the devil. Too many people, too many no entries for comfort. Passengers on the Bakerloo and Central lines, on their way to work or thankfully travelling back home again, occasionally had a glimpse of what was going on. They themselves could scarcely have been expected at that dusty time to raise a cheer. But they might have done if they'd known more of what was being tackled. It was a smuggling adventure, getting stuff down in the night time when people weren't looking, putting it into place within a few feet of the feet of Londoners overhead. Just how difficult an adventure was the challenge which faced the miners of the Victoria Line when they got to the point where there was a store sitting on top of them. The southbound station tunnel had to support the weight of Peter Robinsons. Hats, dresses, tights, undies, and all. The store has 3 basements. While the women were admiring themselves on top, the miners put a concrete raft under their legs underneath. Bread and butter work for engineers, working in tight holes underground. Two worlds. Up above, where everybody feels as safe as houses. Down below, where they carry buildings on their shoulders. In November 1965, the diggers on their way south reached the concrete raft and skimmed safely underneath it. She couldn't care less. A major engineering undertaking was developing under Oxford Circus. Unbeknown to most of us on top, in the isolated underground world, a new bit of London was in creation. London, which has never stood still, was advancing again. In September 1966, a moment of tunnelling history. the final breakthrough under King's Cross of the new Victoria Line. There were no celebrations. Shades of the Forth Rail Bridge. Brunel throwing down his hat to mark where Swindon would be on the Great Western Railway. While the line was building, they tested automatic trains. All the driver has to do, apart from opening and closing the doors at stations, is to press twin buttons to start. The machines do the rest. Coasting, accelerating and stopping, the train looks after itself. In fact, the drivers could have been dispensed with. But it was thought that the public would be unhappy without the sight of an official with manual over-control on board. In truth, the Victoria Line, all its trains along its whole length, is ordered by a couple of men in an operations room by Euston. And even they don't have to interfere unless there's a technical hitch. The driver is in telephone communication with them. He has a public address system to talk to passengers. But, well, all he really has to do on the Victoria Line, I could do myself, and have. Obviously, London can't take all the credit for the new line. The achievement is truly a national one. The electrical equipment was made in Manchester, the rolling stock in Birmingham, the concrete lining segments of the tunnels in Essex, the cast iron for the stations and tunnels in Nottinghamshire, Teesside and Glasgow. This isn't just London's, it's ours. Ever thought what you're sitting on when you travel in the tube? In the experimental phase, they didn't forget the passengers. Iron ones, patient, uncomplaining and heavy, 20 stone each, are provided a simulated rush hour load for braking and acceleration checks. Each experimental train became a mobile laboratory, driven manually and under automatic control. Boffins studied performance, satisfying themselves the way boffins do, with graphs, slide rules and tape measures. They checked how trains would brake in the rain. A precautionary provision in our climate, but hardly necessary, I should have thought, in an underground. Still, you know what boffins are. Enough that they passed us, trains and iron passengers fit for service. Trains can't work without rails. Anyone who has stuck the rails of a toy one together knows how easy it is for the whole caboose to turn over. I wonder how the experts get on with their children's toy trains at home. At work, it's different. The wonder of this operation is that they have to sneak all the heavy gear they need, the rails and the sleepers, down deep working shafts. Because there are only inches to spare for the trains in the running tunnels, the track has to be laid within an accuracy of a 1/16th of an inch. Next time you're in a tube, if you're a Londoner, probably tomorrow morning, notice what a tight fit in the tunnel the train is. Nothing new about a cement mixer. What was new is that it becomes a little more difficult to install and operate when the stuff for the pudding has to be lowered into a netherland and mixed in a plant which in its turn has been humped to the bottom of a working shaft. Millions of tons of concrete were needed for the bed of the new line, all to be shifted load by load through the complex of new tunnels. Just laying the rails called for novel methods. In 300-foot lengths, they were brought to the working sites in special battery-driven trains. They are highly flexible and quick to lay. At the forward ends are chained to the track, and the train, moving slowly backwards, squeezes them out like so much toothpaste into rough position. Then it shoves the flexible bars inch by inch into their chairs, as the engineers term it, and they're secured. You've got to give full marks to work like this. What an ingenious animal man is. Rails for trains, escalators for people. The Victoria line has called for 42 new escalators. When London's first moving staircase began to run at Earl's Court in 1911, a man with a wooden leg, he was nicknamed Bumper Harris, was employed to ride up and down all day to show Londoners how safe and easy it was. Londoners don't need reassuring anymore, but the engineers do. Working on full load, 1.6 passengers per step, 5 tons on 50 steps, the escalator must stop in an emergency in 4 feet, 2 inches average. It does, but carry dogs and fold your pushchairs. After nearly 6 years came Easter 1968. While the rest of us were on holiday again, it was time at last to fold the umbrella over Oxford Circus. They folded it so fast that time schedules went for nothing. The traffic rolled again, but not over the old Oxford Circus. A new wonderland had come into being underneath. You can call this lighting up time. When the hour came last year to open up the first sections of the new line, the signal went to Lots Road to switch on power. An exciting moment for the electrical engineers. They'd done their homework, but they wouldn't have been human if when the signal went to check, they didn't stand and stare. Along sections of the line, not yet to Victoria, other power was on. The pattern of automated transport after years of work was emerging. This is the road to the world of the 70s. Regret the past if you like horse-drawn traffic. But this is where we're all going. No hands. Most people on the platforms don't know yet how closely they're being watched on television screens in master control offices. The girl doing her hair doesn't know yet that it's a two-way mirror with a view from the other side. Not quite Orwell's 1984 or Aldous Huxley's Brave New World, but here it comes, inexorably, unavoidably, inevitably. The machine is beginning its rule. A network of interlocking machines throughout the Victoria line gives communication at the speed of light. What we used to call a pianola, a punctured strip playing the piano for people who can't play the piano, programs the traffic operations day by day of the whole line. Memory banks, automatic traffic signals, spindles and levers show the way. A complete week's programming is on one roll, and it clicks forward from one day to the next one. In the rotunda control room for the whole of the line, two men effectively watch how every train moves, how every passenger moves. With their monitor screens to watch station traffic, telephones to talk to every driver, this is the most advanced underground system in the world. A marvellous contribution to London's traffic problems. A marvellous achievement by the engineers and contractors. To keep up with the modern world, London couldn't have produced anything better than this. But think. This is the way we are all going in the automated age. The automatic barrier with magnetically encoded tickets is the new thing. Regret for the bumbling old world of the past? A waste of time. We are for the future, and if we can't live with it, we are for the past.